Welcome. Today we're talking about similarity in right triangles. Now the first thing we need to do is define a word called altitude. Now a triangle altitude is a segment that's drawn from one corner perpendicular to the opposite side. If the altitude is being drawn to the hypotenuse of a right triangle, it creates two new right triangles. Since each of these triangles shares an angle with the original, plus they're both right triangles, they are similar by the AA similarity postulate. Now we can use this similarity to find missing values. We just have to pay attention to which sides correspond. Each of these right triangles has a hypotenuse, a short leg, and a long leg. We're going to color code to hopefully make this easier to see. So in the big triangle, the original before we drew the altitude, there's the hypotenuse all the way across from C where the right angle is. There's a short leg, AC, and a long leg. Now in the medium-sized triangle, the one on the right, everything moves. Notice the right angle is down at D. The hypotenuse is always, always, always opposite from the right angle. So the hypotenuse now is BC, the short leg is CD, the altitude that we drew, and then the long leg is really just part of the original hypotenuse. When we look at the left side triangle, again, things will change. As we shift our color coding over, remember that right angle is there at D, which means the hypotenuse will move to AC. And then our short leg, AD, and now the altitude is still a part of this triangle, but it's the long leg of the smallest triangle. Now we're going to use what we know about proportionality of similar triangles to find the length of AD. Now that's the short side of the smallest triangle. Since that's what we're looking for, I'm going to represent it with X, and we're going to make a proportion because similar triangles have proportional side ratios. So let's try with a proportion X being the short leg of the small triangle. So we have options here for this. If you joined us for our proportionality video, you know that this first fraction, since I'm using the short leg of a small triangle, I can either make this a ratio between the two short legs or the small triangle sides. Let's go ahead and use the short legs here. So X is the short leg of the small triangle. If we look at the medium triangle, the short leg there is 5. The other sides that we're looking at will have to be the hypotenuses. Now since X was from the smaller triangle, we need the hypotenuse from the smaller triangle to be up at the top, and then the hypotenuse from the bigger triangle, well, the medium-sized triangle, at the bottom. And then this is our proportion that we'll solve. I like to always reduce my fractions first before I start multiplying. So let's reduce 4 over 10, both divisible by 2. So this becomes 2 over 5. We'll bring down our other ratio. But look, our denominators are the same, which means that X just equals 2. And there you go, there's our answer. So the takeaways from this are just that an altitude to the hypotenuse of a right triangle creates 2 more right triangles, and all 3 of those are similar. And since they're similar triangles, you can use proportions to find the missing lengths. Thank you for joining me today, and I'll see you soon.